Hello, Andre.
Hello, guys.
Hi, Andre.
Hey, Mike.
Hi, Mike.
Hey, Caio.
So today, iOS of mentoring number 8. Test-driven MVVM with RxSwift. And the goal is to have an overview of RxSwift and reactive programming. I'm going to be designing and testing models, view models, also testing the reactive state transitions and binding model state with service requests and view model state with the UI. And also handling animations and reloading just partially the table view rather than every time there is a state change, redrawing the whole screen. I'm going to be trying to reload only what's necessary with animations. Make sense?
Yeah, definitely.
So tell us a little bit about yourself.
Well, my name's Andre. I've been working as a software engineer for about 5 years. And currently I'm working on a bank project. And in the last couple of weeks, we've had a task to make a form, to make a screen where a user could fill in banking details to make a payment when he or she can put in the bank account number, put in the payment purpose, and find the payee using the backend API. So, and the design was pretty complicated. So we came up with a solution of a table view, but it was pretty much a big mess because there was a lot of code. And this is the reason why I came to you guys with the question, how would be to make it more properly.
Structure it better. Less code. That's the goal, right?
Yeah, less code, less mess, and more understanding of the way things works for the people who come after us. We need to respect people who come after us.
Right, exactly.
And testability as well, right? An easy way to test.
Definitely.
All right, so you sent us a project demonstrating this feature?
Yes.
Can you see my screen?
Yeah, I can.
Mm-hmm. Yep.
So here we have the form. When you select a field, for example, the IBAN, you want to focus on that field. And as you type, you want to give some suggestions, right?
Yep. And when you press a suggestion, it has some information inside it. And as you could see, the bank name came a little bit later because there was a request.
Mm-hmm. So when we select a suggestion here, it doesn't fill only the IBAN field, for example. It might fill other text fields as well.
Yes, and almost all the fields are optional because backend doesn't guarantee that there's going to be any specific data in it.
Right. And the same thing for the text number. We can also search.
Yes.
And when you select, also it's going to fill more than one field, whatever the backend could find.
Yes.
But the bank name, we don't search, right?
Yes. The bank name, we don't search. It is requested from the server.
Right.
On the basis of IBAN and text number.
But we can edit the bank name.
Yes, we can.
And the comment the same.
Yeah, comment is optional. It just needs to be. It just needs to be. It doesn't really matter currently if it's one symbol or empty.
Mm-hmm. Okay. So that's the challenge. When you select something, you hide the other cells, correct?
Yes.
And as you type, you add more cells to the table view. And when you select, you need to reset the state, go back to all the fields displayed, and update the fields.
Exactly. It's a simple project that I made because I have no right to reveal the original project, and in the real one there's also an amount cell and a source where you could select if it's an account or a card or a deposit, or you could manually plug in the card or account number or something else, the source of the payment. So it's a little bit, in real life, it's a little bit more complicated than in the project that I sent you guys.
Yeah, I imagine. You probably also have a button that is enabled or not, depending on the validation state.
Yes. Yeah, if it's green or gray, of course.
Yeah, it's quite a complex screen, right? It looks simple for the user, but
Yes, very much.
Classic. Yeah.
There's a lot going on here. So what was the hardest thing about this implementation? What was the thing that you're like not happy about?
The thing that I'm not happy about is the way we work with all these cell view models and models, because when you work with a table, usually you think about an array of something, and with these specific cells, you need to address each cell individually. So you need to have a model for a specific cell, you need to have a view model for a specific cell, and right. You need to know which sections, which cells to reload. So this mechanism became like very, very large, probably, I would say. And you also need to observe all the values inside each cell. So you need to observe basically everything. And sometimes when you fill in 4 out of 5 cells, you need to make a backend request to get a bank account or to get financial conditions to show the user if he can or he cannot put in that much money. And you also need to change the balance of an account or a card that the user chose. That's the part that I didn't put in, but I think it was pretty complicated to do.
Yeah, the way I think about table views like this is that every cell should have its own model and maybe its own controller, depending on the pattern you're following. And then you also have a main form controller or form view model that coordinates the cells, because you want to centralize how you control the state. Because if you have many things changing the state at the same time, it's a nightmare. You want to have a centralized observable. For example, the UI will observe it, and depending on state changes, it will withdraw the UI. Rather than having many different signals, many different publishers sending values in different queues and not centralizing them. Because that's how you get in trouble. That's how you get in trouble when you have many things you need to listen coming from different sources, and many things can change the state of the table view. You might even have race conditions. So it's very complicated. It's better to centralize it. So you can have a central view model, and you can have a view model per cell to keep the state.
And as you said, like newcomers to the team, it's almost impossible to understand what is going on. Like when you have all these listeners and all these signals left and right, like it's going to be very, very challenging. Most probably they cannot work like that, you know?
One other thing that was pretty challenging is that basically there are 2 ways that a change can come. A change can come from the user typing it, or a change can come from the user selecting a preset. And here we sometimes had a collision when we were observing the text field editing changed, and we were also observing some text that was set. So sometimes we had a recursion and or simple exceptions, and it was pretty tough.
Okay, why don't we start this feature from scratch? Test-driven.
With pleasure.
All right. So let's create a test. Can call this, what is this? It's a payment form, right?
Yes.
So payment form, view model, tests. Let's create our first test. So as you said, you would like to have a centralized way of defining this state, because the way you think about a form is an array of fields, right?
Yes.
So we can create the payment form view model as this centralized place that controls the payment form. So it knows about the fields inside that form. it controls the state for the form. So let's start here with our payment form. Okay, so we instantiate the form view model, and that's our system under test, the SUT. You're familiar with the naming, right?
Of course.
Excellent.
And what we need here, let's say we need an initial state, right? So we are testing, let's say, the initial state. And let's say the initial state for this form, what is it? Because it has many states. Let's think about that. You have the state where you have 4 fields. You have the state when you have only 1 field. And you have the state when you have 1 field and a bunch of suggestions. Make sense?
Well, in my case, 1 field and a bunch of suggestions, and the one before was the same state. It's just that in the second section you had something.
So let's say the state here is that we have 4 fields. IBAN, tax number, bank name, and comment.
Okay.
That's the state of the form, how many fields you have in the form. So let's say a state where you have fields, and let's say you have IBAN, tax number. So we need to define what is this state property here. We have the state where you have a bunch of fields, and let's say it's a field view model.
Mm-hmm.
And you also have a case when you have only 1 field, let's say the focus state, when you have only 1 field and a bunch of suggestions, for example. That could be suggestion view model, for example. We have this state where we have a bunch of fields, and we also have a separate state when something is focused, we have only 1 field and a bunch of suggestions, which is represented by a different view model, rather than trying to define a very generic view model that works for any field. Let's treat them differently. Things that are different, they should be treated differently at the type level. So we have these 2 states you can be in, and the initial state is a bunch of fields, right?
Mm-hmm.
So let's create here the IBAN is a field view model, and let's say the tax number is another field view model.
This can go in an array in the assertion.
So this is the initial state. Let's say we have only 2 fields to simplify the logic now. And let's return just empty so we see a failing test. And let's make this equatable because this is just data. So we can get the equality for free here. So let's make this equatable as well.
And the state is just a state, not an array, in the assertion.
Right. Failing test, of course.
Okay.
So let's pass some fields for the payment form view model. Let's inject the fields. IBAN, tax number. Tax number. Let's see if we can get the initializer for free. Okay. And now we can set IBAN, tax number, and the test should pass. Boom, we have the initial state.
Okay.
Let's see the next test. What is something that can change the state when you focus on a field, right?
Yes.
Okay, so we can check that.
So IBAN focus state. First of all, it should only include the IBAN field. And the initial state includes all form fields. So let's say if we get the IBAN and we send a focus message to it.
Mm-hmm.
We expect the state now to be
focus IBAN.
Yes.
Right.
But for us to be able to observe this state, we need this state to be
observable.
Exactly. It needs to be unobservable. So let's comment out this test. And let's change this to be an observable now. Observable of state. And the initial one could be just the initial state. So let's import RxSwift. And now we need a way to extract the value from the observable. And we can create a spy for that. A state spy, for example. And it needs with an observable of state. And here we can subscribe to the observable. And every time there's a new state, we need to capture that state. So we can say self.values append state. So let's keep state in a private var values. It's an array of states. Makes sense so far?
Does.
And of course we need to add it to dispose bag. So let's create here a private dispose bag. Alright, so now we can get our state as a spy of the SCT state.
Can omit the observable parameter name.
In the init underscore.
Values.
That's it.
That's why we need to pair. I will waste a lot of time here. Alright, so now we are back to a working state. We can investigate every change that happened in the state of the system under test with this spy. And we know that it had only one state, the initial state. Make sense?
Definitely.
Okay, so let's go back to the other test. When we focus on the IBAN, we want the state to be initially fields, and it should transition, right, the second state, because we're keeping all the states here, so we can actually check all the transitions in that state spy.
Yeah, that's pretty handy.
It should be focus, IBAN, and no suggestions, right? That's the second state. Before you type anything, you shouldn't have anything, correct?
True.
So now we need a way of focusing in the field view model. So here we can create a focus. And what is the type? Should it be a behavior relay or a publish relay? Something that, for example, pressing a button could trigger an event. Like it should be injected. We could use a subject, but subjects can fail and complete. But focusing never fails and never completes.
Yeah, we can try with the behavior relay.
So behavior relay, it's in RxCocoa. Behavior relay. But behavior relay needs a value, but focus is only a string, right? It never holds a current value.
It could be void, no?
Could be void. Yeah, but a behavior relay, every time you subscribe to it, it sends the current value. And the current value would be void, but it would trigger in the subscriber.
Well, we could skip one.
Or we can use a publish relay. A publish relay doesn't have a value. When you subscribe to a publish relay, you only get the next value when there is an event. That's the difference.
Okay.
So a publish relay should be enough to send values into the stream. But now we need to implement our own equatable here.
Okay.
Let's return true because we don't have any values to compare yet. Let's have this dummy implementation. Make sense?
Does.
Let's run the tests. Failed. Okay, so we have a failing test. we're calling focus, but the state is not changing yet.
Right.
So we have an initial state, and we need a way of transitioning this state when some events happen. When the IBAN focus is called, we want to transition to a new state, right? So we can map this event, focus, and we need to forward the new state. What would be the new state after you focus on the IBAN?
Focus IBAN, yes, and empty suggestions.
Yes.
That's it.
So we map that event into the new state we want. But now we need to merge. So we're going to have a centralized observable that will combine every state change and deliver in a single pipeline the new state. So we can merge the observables. And now, if this event occurs, we're going to get a new state. And the initial state is the fields. Make sense?
Well, I'm a little bit lost here right now.
So we have two observables here, right? We have the IBAN focus, and we have the initial state.
And the result of the merge will be observable state?
Yes, you can merge a collection of observables into one single observable. So anything that fires here will be merged into one observable.
Okay.
And that's the goal when you're defining state transitions in a reactive way. You want to have multiple streams or events that can happen, and then you keep combining them, merging them, concat. There are a bunch of operations you can perform to combine, merge, concat streams into different streams, mapping the values, flat map. For example, here we get a focus event, and we map it because this focus event is void, right? And we map that void into the new state. And we know that when it's an IBAN focus, the new state is focus IBAN. So it's in a centralized place, all the state transitions.
Mm-hmm.
And the test is passing.
Cool.
So initially it was fields, and when we call focus accept, it transitions to IBAN with empty list of suggestions. Now we want to do the same thing when there's a text number. So when we focus on the text number, we want the transition to be focus text number. Let's run the test. Should fail. It does. And we need to do exactly the same here. We get the text number, focus event, and we map it into a focus text number now. Passing.
Does that make sense, Andre?
Yeah, it does. It does.
So the idea is to centralize the state transitions so the user interface will listen to one single state observable and react to those changes, rather than having to listen to many separate, distinct signals. This is what simplifies the state transitions. You combine all the things that can change the state of the screen into one observable. Okay, so the test is passing. Now let's do some refactorings here.
Yep, got a couple tests already.
So we have a bunch of duplication here. Let's create a make SUT function. Private function make SUT. This should return, let's see, we need to return the fields and the system under test. So the system under test and let's say fields. And fields is going to be IBAN, which is a field view model, and text number, which is a field view model. And we can move this logic here. Return SUT and IBAN text number. So now we can create SUT and fields from the make SUT function. And this is now fields.textNumber.
Mm-hmm.
Make sense?
It does.
And here we don't need the fields, do we? Oh, we do.
We do, and we want the IBAN and tax number to come from the fields, so perhaps we can have a combination of all the fields.
Yeah, because if we add new fields in the future, we're going to break a bunch of tests, right?
Right, exactly.
If we add new fields, and we want to add the bank name at the comment, we will break a bunch of tests, and we don't want that. So, okay, we can create here, let's say we have the fields, IBAN, tax number, and we can maybe have all, which combines all of them, which is a collection.
Yeah.
Okay. So we need to pass now collection IBAN tax number. So here we can just say fields.all. So we want all the fields initially.
Yeah, and we don't need the array as well, because this is the array.
Right.
All is the array.
Okay, I like the refactoring.
Yeah, very neat.
And here it's fields.IBAN. Fields.tax number. So the tests, passing, eliminated some duplication. It's good. Anything else you see there?
I think that's it so far.
Andre?
That looks very good. Make SUT looks pretty scary, but the rest looks better.
It's only scary when you declare it. When you use it, it's awesome.
Because let's say now we want to see what happens when you focus on bank name. What is the state transition? Shouldn't change the state, right?
Right.
Yeah, it shouldn't.
So doesn't change state. So let's say now we want to add a bank name. We can just create here our bank name. We can just add a bank name here, field view model, and pass it through to the view model. Field view model. Now this is bank name. So that's how we can add new fields without breaking all tests. The tests have this abstraction, all fields. And of course we need to add the bank here, because we added a new field.
Mm-hmm.
Okay.
It's not passing. Here, we don't want a state change, correct?
Yep. Yep.
What happens when I select the bank name? Nothing.
Yeah, that's true.
Nothing happens, okay.
Nothing happens. Should be all.
All right.
That's
so we
it.
got the behavior we want. Now we can do the same thing for the next one. What happens when I select comment?
Nothing happens.
So nothing happens right now, but maybe there will be a requirement in the future that some requests might be fired, you know?
Yeah.
There might be some side effects from doing that. Okay.
Actually, there is a requirement once you complete typing a comment. If everything else is filled in, you need to fire a request.
Right. So as soon as the whole form is valid?
Yeah, but you can change it as well.
Right. We need to pass now the comment here in the initial state. So that's it. We added 2 new fields without breaking the previous tests. And that's the goal.
Yep.
And in the future, we could have like a button view model, for example, you know, if you need a button to actually submit the form,
Mm-hmm.
you would create something else, like a button view model. Okay, so we know that there are no side effects when you focus on the comment. That's good. What is the next thing that should happen? When I start typing the IBAN, it should request something from a service, from a backend, the suggestions from the backend.
Right.
Is that right?
Yep.
Okay.
So IBAN, let me copy this one. So let's say this IBAN now, it has a text relay where we can send new states like a query.
Mm-hmm.
Let me add here. So this is a behavior relay, right? Because you need to keep the state, the current state, the text. What is the initial value? Empty?
Yeah.
Okay. So we have an empty state, and when we send a new value here, we want this to be transitioned to fields with some suggestions that comes from a backend. Make sense?
Yep.
Okay.
So we need some kind of suggestion.
Yeah.
Which is an array of, I don't know, suggestion as a model.
Mm-hmm.
So let me create one here. Let's actually instantiate some of them. Let's say 2 suggestions. And we need a way of injecting these suggestions.
Right. As you said, this might come from the backend, right? So
Mm-hmm.
we should have some sort of mechanism for requesting the suggestions.
Okay, so let's think about that. We need a service, right? A separate object that will perform this request. We don't want the view model communicating directly with URL session or RL modifier or any networking library. Agree?
Yep.
Yeah.
So we can create a protocol, suggestions service, and it can have a method perform request. It's a suggestions request. It needs a query, right? It's a string.
Yep.
Mm-hmm.
And it needs to return an observable of suggestions.
That's it.
Does it look right, Andre?
Yeah, it does.
Okay.
Well, probably maybe not an observable, maybe a single, because it should fire once. Yeah.
That's it. So we have our service, and we need to inject this service now here, right? In our view model as well. Let's say we have a service as a property, suggestions service. This is going to break our make SUT.
Right.
So we need to pass a service here. Well, we can create a service stub.
You can stub it. We stub the suggestions as well. So it's going to work.
Okay, so let's create some predefined values here. A stub is a query and suggestions. So suggestion. Cool. And perform request should return if the request query matches the stub query, we return the stubbed suggestions,
mm-hmm.
or we return empty.
Yep.
You either use the stubbed query and get the stub suggestions, or you get nothing. Empty collection.
The stub on 149, we need a value there instead of just the string type.
A query.
That's it.
So now we can provide this stub here.
Yeah.
Okay, so we don't break the other tests because we have a default value.
And there's a typo, there is service. Yeah.
Okay, back here. Now we need to create our stub service. Pass it in here. And we need to accept the service stub query and make sure that we go back the service stub suggestions. So we don't need the suggestions here.
I think it's expecting view models in the state, not the suggestions.
Right.
Okay. Good catch.
Yeah, so we could make the service return suggestion view models, but I think that's a leaky abstraction because the service is in a higher level.
Yeah.
So the service should return simple models, right? Like the suggestion here.
True.
Exactly. The service should know about view models.
Yeah. So we need a way of mapping that. So maybe we can start this. We can create a suggestion view model from a suggestion. Let's say suggestion. And it doesn't have any values yet. Because that's how I like to define my types and my values. I only create things when I need them. So I let the type system and the tests guide me. What do I need now? What do I need now? And only do the minimal amount of work at every stage. So we can create now view models from suggestions, which means we can, let's say, map this into view models.
Yeah.
Fantastic. Just need to rename this.
About text changed state, no.
Text changed provides suggestions based on text.
Yeah. Based on the query, based on the text.
Okay, let's run this test. Hopefully it should fail because we're not doing this yet. And it does fail. Okay. So we need to add a new event here to our state. And this is IBAN.text. So when there's a change in the IBAN text, we need to map that. And we get here the query. And we need to perform a service request. Is that correct?
Yep.
So when there's a new text change in the IBAN, we want to make a suggestions request. So it's service dot perform, and here we create a request with the query. But this returns an observable, while it returns a single. So we can use a flat map here. Otherwise, we're going to have an observable of observables. But what we want is an observable of state.
And can you cast it as observable?
Yes.
Okay.
Cool. But this returns an array of, the result of that is an array of suggestions. But we want suggestions view models.
So we map it.
So we need to do suggestions dot map suggestion view model. Well, it's a focus IBAN with suggestion, right? And that's the new state.
Yep.
It's just not IBAN, it's IBAN.
Okay. Let's run the test. That should do it. Nope, we broke everything. Now imagine doing this without tests.
Ouch.
Okay, the problem is that, remember that I said that a behavior relay emits a value as soon as you subscribe to it. It emits the current value. So as soon as you subscribe to it, it fires the current value. And we don't want that, only when it changes.
We can skip one?
We can skip one, yes. Skip one. Okay. That should do it. Boom!
Awesome.
Now without tests, one simple signal you forget to add there, one transformation you forgot to add into the stream, will be firing this request when not needed, for example. So without tests, it's very dangerous to use reactive programming style. It's very hard to keep track of everything that is going on if you don't have a way of making sure that the state transitions work accordingly.
Right.
Or you have a lot of time to test.
Well, you see, like one small change, like adding a skip, changes the whole game. It changes the whole thing. And it's so easy to add this and not run all the manual tests all over again. It's just a skip. What bad can it do if I remove this skip? One line of code, like one chained operation, can break everything. So, okay. Another problem I see with reactive observations is that when you update the text again, it would fire again the request, even though you already made a request for that query. Does that make sense? The text changed, but it changed for the same value that was there before.
Yeah, we can avoid that.
So I can run the test and see it fails, because now we have these two straight transitions here. And we don't want that, because now we're going to be firing requests that we don't need. We want only one. So we can use another operation called distinct until changed. So we're going to ignore values if they match previously emitted value. Make sense?
Yeah, it does.
Boom, test is passing. So if the IBAN keeps sending events for the same text, we ignore it until there's a new text. So we make a request there. Or maybe you want to perform the request all the time. Then you make sure not to have the distinct until changed. It depends on your use case.
You add the test, right?
Yes.
You make sure you document that by adding a test.
What about the tax number? When I type the tax number, should I make a request as well?
Yeah, you should.
So tax number now should return tax number with the suggestions as well. So this should fail. Yes, it does fail. So we need to do exactly the same thing, but for the tax number. Duplication.
One step at a time.
Let's run the test. If it passes, we refactor. Okay, it's passing. So when you change the tax number, we fire a request, and when the request completes, we provide a new state. Fantastic. Now, let's put this in a function, in a helper.
These two are the same, so...
So what is this? It's a search, right? It's a...
Yeah, right. It's a search.
Search for a specific field. And this returns an observable of state. So we can copy this in here and replace, instead of IBAN, we're going to have a generic field. And field here as well. That's it. Now we can replace this with a search for IBAN and search for tax number. Run the tests. If it passes, we're good. Boom.
Nice.
Fantastic. What else? So, what should happen when we change the bank name? Nothing.
Nothing really.
Bank name text change state doesn't change state. So we don't need a service here. And this is the bank name. And since we don't expect any side effect, we do it only once.
Right.
Any query. Doesn't matter. Any change to the bank name should not alter the state of the form. Okay. So this test passes straight away because it's just a safe net, to make sure that we are not doing something when we shouldn't. This will save you from bad refactorings,
Increasing coverage.
Yes. I think that's all the state transitions, right? Oh no, when you select a suggestion now.
Yeah.
Okay. What happens when you select a suggestion? You need to go back to the all fields.
Right. So we lose the focus and we go back to the form with all the fields, right?
So IBAN suggestion selected state includes all fields. That's it. So we are going to expect that after you select it, it should go back to fits all. So the transition is initial state, after there was a text change, and then when you selected a suggestion. Make sense?
Yeah.
So now we need a way of invoking a suggestion. We can get the suggestion from, it's inside here, right?
Right.
In the state. So when we fired an IBAN text change, we will be in this state, the focus state. So let's say switch state values dot last case let focus suggestions. So we get a bunch of suggestions. We can say suggestion, let's say the first one, dot select. So we're going to fire a selection in the suggestion. Default, we're going to fail. Expected suggestions in the current state. So let's say where suggestions.
Right. It's not empty.
It's not empty. Okay, so if we have suggestions and it's not empty, we fire the suggestion, otherwise we fail because we are in the wrong state. So now the suggestions view model should have a selection relay. And here's why I like to separate my models from view models. For example, my suggestion model, I don't want my suggestion model to know about RxSwift. I don't want my main models knowing about RxSwift, a framework.
Or selection, right? In this case, why would the suggestion know about selection in this part of the system?
Yeah, because selection is very coupled with the user interface, right? With the view model. So it should be in the view model rather than in my main model. My model doesn't know about UI, doesn't know about RxSwift or any other framework. It should be a simple struct or simple class that doesn't inherit from anything. Does that make sense?
It does.
Okay.
Okay, so we have a way of selecting a suggestion. So again, we need to implement equatable. And for now, let's just return true, because there's nothing to equate yet, but we're gonna get it there. Okay, failing test. We are selecting the suggestion, but the state is not changing. So we need to add a new way for this to happen. How can we observe suggestions?
Selections of suggestions.
Yes. I think we need a new stream for that. So private let, what is it? A suggestion selection is a publish relay of void, right? It's just a stream where we can send events to say something was selected. And we should inject that selection into the suggestion view model. So we can use another initializer, suggestion, and the select, which is a publish relay. Okay, so instead of the view model creating its own relay, we're going to inject a relay into the view model so we can observe it from the main view model. Make sense?
Yep.
So here we need to call this initializer just so we don't break the tests right now. Then we can get rid of this. Let's just create a relay here. So instead of creating it, we receive it. Okay. So here when we create our view models from the suggestion, we need to create it with the suggestion and the suggestion selection. That's how we can observe selections on specific view models. Okay, so now we have this mechanism for injecting the relay into the view model. Now we just need to observe it. So what happens when a suggestion is selected? We want to map it and return a new state, which is the same as the initial state, correct?
Mm-hmm. Yeah. You tap, and then the form comes up.
Okay, so we added this new thing into the chain. Every time there's a selection, we are going to return the initial state, all the fields. Make sense?
Yeah, it does.
Let's run the tests. It's passing. Nice. So let's refactor this actually, because this is ugly. Look at this thing.
Yeah. We can do better.
We can create a test helper to extract the first suggestion from the state. So let's create it here. Private extension state. Let's say first suggestion. It's a suggestion view model. Correct?
Mm-hmm.
Switch self. Case let focus with suggestions. It should return the first one.
Yeah.
Default new. That's it.
Okay, so it's exhausted. Yep.
Right. So now we have a simpler way of getting a first suggestion just so we can invoke it. So suggestion equals state dot values dot last dot first suggestion. But this returns an optional. So we can unwrap it. XCT unwrap. Cool. And if it fails, we set this message. If it fails to unwrap.
Mm-hmm.
So this needs to throw. Suggestion, select. Cool.
Mm-hmm.
Awesome. That's it.
Now we can do the same for the text number. Exactly the same. Okay.
Mm-hmm.
We've proven that selecting a suggestion, regardless if it's coming from the text number or not, will set the selected state. So I think we are done. I just want to look at these models now, because you said that this suggestion here, it has the IBAN, right?
Yep.
And it's optional.
True.
And the text number, which is also optional.
Exactly.
Okay. What about the field view model? Are we missing something here?
Well,
Oh, we have the title, right?
yeah, we also have a title. Yep.
What is the type of the title? Does it change or is it fixed?
No, it is fixed, and it depends on the kind of field. So it's just a string.
Okay, so not to break the test, let's give here a default value. But now, if we have a title, we can compare the view models per title.
True.
So let's create a new test case. Let's call it field view model test, and test is equal when title matches. Make sense?
Mm-hmm.
Well, but it also has text, and the text also needs to match, right? For it to be equal. So when title and text matches. So let's create here. Field 1 is a field view model with title, a title, and another field, let's say another title, and they should not be the same. Something is broken. Okay, so we need to pass some values here. Let's give it 1, 1, 1, 2, 2, 2, 4, 4, 4. Cool.
Nice.
Now the test is failing. Let's return false. Passing. Next test. Let's make sure f1 is equal f1. Title equals title. F3 is the same as F1 title, but F3 text is a text. Now F3 and F1, they have the same title, but they have different text, so they should not be equal.
Yeah. Excellent.
And text value is equal text value. Let's run the tests. Oh.
What field?
It should be text number here.
Okay.
Okay, passing. Let's move this into a new file. Okay, so this field view model now has title and text. And the suggestion needs also some text, right?
Yeah.
So let's see. Suggestion view model tests. Test text is based on provided suggestion values. So if I create a suggestion and I give it an IBAN, I don't know, 1, 2, 3 and text number 4, 5, 6. If we create a suggestion view model, assert equal should be that the system under test text, let's say, should be IBAN 1, 2, 3, text number 4, 5, 6. Just to simplify this use case. Does that make sense?
Yeah, it does.
IBAN is suggestion dot IBAN or empty, and text number is suggestion text number. Let's force some rapid now. Let's run the test. Oh, they should be equal. Yes. And what should happen if the value is not there? So if IBAN is not there,
We just don't mention it.
so we show only the text number. Correct?
Yep. Correct.
Without IBAN. They should crash now. Okay, it failed.
Yep.
So now we need to unwrap this thing. IBAN and text number. So case some IBAN, some text number. We have covered here.
You need to say let.
Okay. And case let none and some text number. You want just the text number. Okay. Now without text number should be IBAN 1, 2, 3, right?
Yeah.
What if we have no suggestions?
Can it happen?
Well, you definitely can define that, right?
Yeah.
Oh, no IBAN and no text number. I meant when you said no suggestion, you cannot create a suggestion view model without a suggestion.
Yeah, I meant without the IBAN.
Okay.
And text number. Yeah, but that's a better name. Let's run the test again. Okay. Let's move it to a new file. Exit test. Import. Run again. Okay, I think we are covering all the state we need here. The suggestion has a text and you can select it, right? The field has a title, has some text, and you can focus on it. You have all these transitions that can happen depending on what happens with the view models inside the form. And it's all centralized in one observable. And you have an external service for performing requests that returns an array of suggestions. So you have the suggestion query, it's just a query, and a suggestion may contain an IBAN, it may contain a text number.
I'd suggest one improvement.
Yeah.
In the merge function.
Observable.
Yeah, in the observable merge. I think we could make a let that would contain all the initial fields and the one in the just.
Right. Okay, so then we need to return here.
Yeah.
Should we say all fields?
Yeah.
This is in state.fields.
Yeah.
Right, and we don't need to capture this thing here. Nice. Can probably create a function to remove this application as well. Like private function focus for field that also returns an observable of state. So here it's field. And we call here focus for IBAN.
Mm-hmm.
And focus for text number. That looks nice.
Yeah.
Much better.
Fantastic. That's it. Those are the things that can trigger state changes. It's easy to see. It's easy to change them when they happen.
It's amazing.
Okay, let's try to put this in the screen. So let's move this to production. We'll just put here in the app delegate. Right. So we need to import RxSwift, import RxCocoa. All right. So we have our view models. Now we need a view controller. And this is a payment form view controller. And let's say it's a UI table view controller, right? It's a table view.
Yeah.
So we need to instantiate it with a view model. So this needs to be on optional. And in the view did load, we need to bind the view model with the table view.
Right.
And we want to analyze the state that changed and only update the screen where needed, correct?
Correct.
We want to react to the states.
Yeah, because I noticed that in your project, you are controlling the updates from the view model as well. And I recommend against it because it complicates a lot the view model. And now the view model gets coupled with table views or collection views. What you can do is make the UI observe the state, and the UI makes the decision which rows to update.
Okay.
And if you're using RxSwift, they provide bindings that does exactly that for you. You just need to define a data source. First, we need to import RxDataSources. Are you familiar with data sources?
Yeah, I used them a couple of times, but only in the test projects.
Right. Let's use one here.
To me, it's not obvious how they work. I prefer to see self for row at index path.
Right. If you do it yourself, then you need to handle all the state transitions yourself, right?
Yep.
You don't get these facilities for free. When you're using RxSwift, you get all these bindings for free if you follow their conventions in the UI side. So let's see. If you create a Rx animated
table view. Yeah.
data source, table view, that's it. And you need to define a section that conforms to animatable section model type. So let's create a type 8 as here because those types are going to get out of hand very quickly. It's an animated section model. It has a section and an item type. What is our item type? Well, I think that first of all, the section type, model type could be just a string.
Mm-hmm.
Now, the cell type is what? Field, view model. Well, sometimes it's a field and sometimes it's a suggestion view model, right?
Yeah, true.
So we need a type to disambiguate this. Let's call it a cell view model. So if it is, what is it? A field? It's a field view model. Or it's a suggestion. Suggestion view model. Okay. So that's the type for the section.
Mm-hmm.
But if you're using these data sources, it requires you to conform to this identifiable protocol, which is very similar to the new identifiable protocol in the Swift standard library. So let's make it conform to it. It needs to implement identity. So I think we can use the identity of the modules inside the cases.
Right. They're gonna conform as well, so
yeah. So case
can delegate that.
Field. Every view model here needs to be identifiable, but you can implement it as extensions in the UI side. Your view models don't even need to know about data sources. So here is the view model, and we just return view model identity. In case suggestion, we return the view model identity as well. Okay, so the field view model needs to be identifiable as well. What identifies the field? What is something that is unique to the field?
Title.
Yeah.
Okay, for this use case, the title is enough. Okay. Now, the suggestion view model also needs to be identifiable. What identifies a suggestion? Probably the text, right?
Yeah.
Mm-hmm.
Oh, it's identifiable type, which is the RxSwift protocol. Okay. What now? It also needs to be equatable. Okay. It only holds data, so that's fine. Equatable. Yeah. Now we need to define a cell configuration. So we get here a data source, the table view, the index path, and the item. Okay. So configure cell is the cell for row at index path. So whatever code you would have in the cell for row at index path, you can add it here. So which view controller you have the cell for row at index path?
It's in, you see a folder screen?
Yep.
Yeah. There's one view controller there. I think it should be there.
Okay, cell for row at index path. Okay, copy this. Here. But in our case, we have these new models. So now the model we get here, this item, is the model we set here.
Mm-hmm.
So we are getting this cell view model for this index path in the table view. And we need to return a cell in this closure. So this is the cell for row at index path from the delegate, but in a closure form.
Okay.
So the item has two cases, right? We have the suggestion.
Yeah, let's do the suggestion.
And you have the field. And they both have view models inside. Okay. So the suggestion, we just set the suggestion. Is it text? Yes. So it's just a simple cell, right? No fancy stuff. And the view model now, we need to create a requisite cell. So we need to configure it, register it.
Mm-hmm.
So let's register the cell. So it needs to match the same setup you would have in your data source implementation. Now, can we reuse this cell?
Yeah, I think.
Because it expects this requisite cell view model, which is your old protocol. But now we want it to use our field view model that we just created. So we don't need to hold a reference to it. We need to get the view model text. Do we need to subscribe to it, or can we just bind it the input text field? So when there's a change, it notifies the view model.
Right.
True, yeah.
But we can use the Rx way of binding.
Rx.
Rx. Dispose. Do we have a dispose bag already? Can I use this one?
Yeah, you can.
Okay, so the text is here. We're not handling error right now. Let's ignore it. What is this keyboard thing?
It's basically the logic of the focus you did.
Okay, so we don't need it.
Yeah, and as you see, the cell observes it's enabled or not because the decision about showing the keyboard was made from the view model.
Yeah, which is the focus, right? Okay. So when this button is pressed, this handle tap, it becomes the first responder. So we probably need to bind here then. Bind the tap of the button to a VM focus. So every time there's a tap, it's going to forward the message to the view model focus.
Right.
And of course, dispose by the bag. Okay, so here we're binding the text with the text field, but we need to do the other way around as well. When the text field updates, we need to pass it back to the view model, right? Let's keep the first one and bind the text changes back to the view model text and dispose.
Does a bind statement hold a strong reference to a self?
To a self?
Yeah, well, when we put input text field, we don't have to put self, right? So self is not retained, right?
Yeah, no, because it's binding to the return of this thing, right? Which is a control property. There's no reference to self. And that's the benefit of not subscribing to it. If you subscribe to an event, then you need a reference to self inside of the subscription to forward the message. But when you bind to the memory is managed by how long you keep the dispose bag, right? And I think you renew this dispose bag every time you prepare for reuse. Yeah. So that's it. Every time you prepare for reuse, all those bindings go away because there's a new view model, right?
Thank you.
Okay, I think that's it here. That should do it. Let's go back to the app delegate. Let's see if it compiles now. Yes. So this is the setup. This is the code you had in the cell for row. You just adapted to these new models. But this is the cell for row. You see, you get the table view, the index path, and the current model for that index path. And you do the logic you need to do here. And you can also set, for example, data source dot title for header in section. And here you pass a closure as well that makes a decision on the title, you know. So you have all the methods you would have in an implementation of the table view data source protocol, but in closures. You pass closures rather than implementing the protocol.
I see.
So, okay. Now we need to get and observe the view model state changes. So view model dot state, and we need to map that state of the view model to something that can be rendered on the screen. So we get the state here, and it can be fields with fields. And we also have the case focus with one field and a bunch of, well, and maybe some suggestions. It could be empty. And we need this to be an observable, because we are mapping an observable, it returns another observable. But it's an observable of sections to bind it to the UI.
Mm-hmm.
Because the table view doesn't know what this view model state is. So we need to translate it to something the UI understands. And the UI understands this section model here. So we need to return an array of those sections for the UI. So when we have fields, we're going to return only one section with all the fields. Or we can create many sections, one for each field. But I find it easier to just do it here. Let's say here we have the fields section, and it's an array of all the fields mapped into cell view models. So we are mapping this state into cell view models. So we get fields, we need to put them inside the cell view models that the UI understands.
Mm-hmm.
Now for the focus, we are going to have still the fields, but only one field. And another section for the suggestions. And this is the suggestion.map cell view model.suggestion. But of course, this view model here is an optional, isn't it?
Of course.
So let's unwrap it. Otherwise, if you don't have a view model, don't render anything.
Else, you need an else there.
Okay, can we compile this? Suggestions. Yes.
Yeah, this should be .field, right?
Like this?
The array outside. Yeah.
Fantastic. So here we are transforming the view model state into sections that can be rendered on the screen. And here we are setting the closure that will render the cells for a specific section. Make sense?
Mm-hmm.
So this is the cell for row, and this is just a mapping from the view model state to a UI state. And now we need to bind sections.bind to table view Rx items, passing the data source. And of course, we need to dispose that with a dispose bag. So we need a dispose bag. Okay. Now we need to set that.
Right. Instantiation.
Let view model equals payment from view model. And it has a bunch of fields. So here the view model for the IBAN, the title is IBAN. Tax number, bank name, comment, and we need a service. Well, let's create a random suggestions service. So here we need to perform a request. We can return a just of 10 values is enough, right?
Yeah.
Just for demonstration. So we had a suggestion with IBAN, let's say int.random, something like this. some random numbers. Okay, that should do it. Now we need a view controller. It's the payment form view controller with a view model. And let's see.
Yeah.
Whoops. Right. So when you're using RxDataSources, you're not supposed to have a data source by the time you register it. And since we're using a UI table view controller, it already sets itself as the table view data source. So we need to do table view.dataSource nil. We need to set the data source and delegate to nil. So it works nicely with the Rx data source. Boom. Look at that.
Nice. Fantastic.
Let's select here the IBAN. Boom. It changed. Now it performs the queries with random values. And if we select, nothing happens because we need to bind now the UI with the selection. Table view Rx dot model select, and the type of model is cell view model, and we can subscribe, and here we get the model. Okay, and what do we want to happen here? If it is a suggestion, it has a view model. We want, well, first to release the keyboard. So this is a UI decision. I don't want the view model knowing about keyboards.
Mm-hmm.
It's too much to keep track in the view model. So here we inject some side effects. And we also want to select that specific view model.
Yeah, file selection.
There it is. So if we search here, we select, it goes back to the full screen. But if we focus on the bank name, it does not focus. The comment does not focus. The text number focus. And you can also search, select, and go back to the previous state. The only thing we haven't implemented yet is validation. And when you select something, you want to update the view models, right?
Yep.
That's it.
You can implement these two features as an exercise, and you can test drive these two features. But when you select something, you want to update these two views. Following the same principles, you want to add these events into the chain and redraw the UI if necessary. And then you get all the animations for free. If you have decentralized place and you have these models, you get all the animations for free.
It's amazing.
And it's pretty amazing how you can do this with RxSwift in what? Less than 200 lines of code. We have this very complex form talking to services and kind of crazy state transitions in what? Less than 200 lines of code, including the UI. Because we have decentralized place for controlling the state of the form. And how many protocols have we created? Only one. And it's super testable. We only abstracted away the service. We can add more fields here very easily. We can add new field types. We can have a button view model or a special field type or toggles.
It's fantastic.
And that's the idea. We are injecting the view models here. But if you don't want to inject only during tests, you can have like predefined values here as well,
Mm-hmm.
You may make a decision that you have default values for them. And everything is a struct. Very simple. There's no reference of self anywhere. Look at this. All these transitions happen. There is no self, which simplifies a lot. You don't need to care about memory leaks here. And you have 100% coverage for all the transitions. Anything that goes wrong here, you're going to have a failing test. And if every time there's a new feature, you add the test first, You make sure that state transitions happened as expected. That's it. And how fast are those tests? It's insanely fast.
It's pretty easy to write as well. You just assert the state that you get, right? That's it. You're spying on the state.
And another important thing is separating your core models, like this suggestion request and the services, from the view models, from the view side of things. Because you can use this service in any other UI. You can use this suggestion in any other application. We can have this abstraction in a separate module that can be reused. So you separate. View models depend on services. Services do not depend on view models or UI.
Okay. Can I ask you one question?
Yes.
I had a trouble when I tried to test drive this project. When I tried to assert that some UI element responded to my view model. So, for example, view model toggled that it has become active, and some text field had to become first responder.
Right.
And I couldn't do it straight away after this change, because probably it happens either on different thread or the observable doesn't have enough time to respond. So how do you test if a UI element is active or has reacted to some UI change?
So I saw that the requisite cell has a become responder here when you tap.
Yeah.
So let's test that. Do we have tests for the requisite cell?
I think we do.
But do we have tests for the first responder? No.
No, we don't. Well, this one, the one that's, as you see, wrong test, number 2, that I commented it to ask you the question further on.
Okay. Let's have a look at this. So this is not passing, right?
Yeah, it's not.
Let me run. So you're saying that when you send the event, keyboard enabled, you would like this to be true, which means it is the first responder, right?
Yeah.
So for this to work is a bit tricky with UIKit. The view should be in a window hierarchy for those things to work. So we can create here a window. And we can say window.add subview. SCT is a view, right? Yes, it's the cell. It doesn't need to be the key window, but it needs to be in a window hierarchy for those transitions to work.
I see.
There you go. Yeah, it's a bit tricky. I don't know, you need to know UIKit for a long time and have wasted hours and hours and hours.
Yeah.
Or know someone that knows it and save a lot of pain. But that's it.
Thank you. It's like this last test is just a blessing.
It's so easy, right? You thought it would be super complicated.
Yeah.
Yeah, that's it. You just put in a window and you should be fine with the input text. Well, since iOS 10 at least. I remember that before iOS 10, it was more complicated than that. It had to be the root window.
Okay.
It doesn't anymore. It needs to be a window.
Okay, I see.
That's it. Okay, so we covered designing the models, test-driven, designing the view models, test-driven, services, binding the services, binding all the state transitions together, and binding the view model state changes with the UI in the form with animations. And now you need to implement the validation on top of this logic. And when you select a suggestion, I want to see the models updated and the UI updated as well. For example, if I select a suggestion that has an IBAN and a text number, I want to see that reflected in the UI and in the model. Make sense?
Yep.
So I'm going to send you this project. Well, I'm just going to push it in the separate branch in your repo. And you can carry on from there. And if you have any questions, you can ask us. But for this session, do you have any other questions?
No, I don't.
Does it make sense? Because I know that it's very complicated to understand this. It took me a long time to understand how to think in this reactive way. Because when you start using reactive frameworks like RxSwift, you want to subscribe to everything when the idea is to combine those streams and think about state transitions over time. You have an initial state, and then you have a transition from that state depending on some event and depending on other events and other events. You should target to have like these separate streams, but combine them, and when you make this shift, things start making sense. It's easier to test, it's easier to design, it's easier to maintain, but it's not easy. You're going to have to practice a lot.
Yeah. I remember when I was like many years ago with Caio, when we used to do this reactive stuff.
In the Objective-C.
Yeah, it was Objective-C back then. It was another library. But yeah, in Objective-C. And I remember when I started learning this, my instinct would be to subscribe to a signal and then just, accept the value. So inside the subscription block, I would just fire another signal. And this is the problem there, because you create side effects, right? So what you want basically is just like one endless stream of stuff and just putting operators in between, and just transmitting the values that you want and listening to these things. But yeah, exactly. It takes some time it's not, it's not easy to think like that, especially if you're coming from procedural. And then you have like I think the other natural instinct that plays is mixing procedural and like this functional reactive way of doing things, because you're not sure how can I do it purely in a reactive fashion, right? You just don't know that. So you're going to mix it. And yeah, that's the path though. At some point it's going to click.
Okay, so no mixing?
I don't see another way. Like, you have to go through this. I think.
If you mix, you're going to get the worst from both worlds. That's my experience. If you're going reactive, I would say just use operators on the stream. Avoid subscribing to things. In the view model, you should just combine different events. If you go back here to the view model, you'll see that there's no subscriptions here. We just combine different events into a main event. Every event that can mutate the current state of the view model is combined into one, is merged, and they dictate what is the current state. And based on the current state, the UI is going to subscribe to the current state, compare to a previous state, calculate the change set, and only update what is needed. So it's very efficient as well. But if you start adding self in the middle here and start adding a lot of side effects, I don't know, it's going to start getting a bunch of bugs that is very, very hard to debug. You start having threading issues as well, But if you just combine memory leaks, you just combine streams with operators rather than subscribing and performing side effects inside the streams. Only at the outer layer you're going to subscribe to it, like in the UI. The only subscription we created here was the selection, because we want to perform this side effect in the user interface to dismiss the keyboard, and that's it.
Any questions, remarks?
Well, maybe just one about the XC unwrap.
Yep.
XCU unwrap. Does it not break the CI if it throws?
Here.
Yeah.
No, because when it throws, XC test is going to catch that and generate a test failure rather than propagate the error. Makes sense?
Okay.
It doesn't propagate the error.
Yeah.
It generates a failure for this test.
Oh, nice.
So that's it. You can throw inside tests, and that will generate a test failure.
If you simply throw, it will generate a test failure, not a CI failure?
No, I don't think so. Yeah.
Okay.
Because if you see the implementation of XC test, they wrap this in a do catch and generate a failure rather than propagating the error.
And if you force unwrap it?
Then it crashes.
You get a crash, yeah.
If it's new, it's going to crash.
Okay.
Yeah, and another exercise you can do in this test here is like there's still a lot of duplication here that you can create helpers for.
Yeah.
Yeah.
Okay. Is that it?
Yeah, no further questions. Really, thank you very much, guys, for this mentoring session. I've taken out a lot, really.
Absolutely. Thank you.
Is this what we were looking for?
Yes, definitely. Like, I haven't seen RxSwift use this, I don't know, artistically. It's really elegant solution.
Yeah, it's a completely different way of thinking. Because if you're used to OO or procedural code, when you're using a framework like RxSwift, you're going to try to build your code base following the same principles you knew before. The same thing if you're used only with reactive programming, when you get into a OO code base, you're going to try to enforce that as well. It goes both ways. So if you're going reactive, you need to think reactive, and it's completely different. So you need to practice, and with time, it's going to start making sense. Every time you need to subscribe, you stop and think, is there a different way of chaining those operations rather than subscribing here and firing some side effect? Try to work with values. You have values that change over time, and some other clients will observe those changes and react to them, or combine them with other operations and perform other side effects.
I would also suggest if you're looking how to accelerate your progress with the reactive stuff, just look into other platforms. They have so much more content that you can learn from. Again, it's the same mindset, right? It's just a standard. You have like this Rx standard, and you get the implementations with different platforms.
Yeah, and RxSwift follows the Rx standard. So if you check the Rx documentation, which is a general standard, you will be able to understand everything and use in RxSwift. The naming conventions are all the same.
Yeah.
Like map, flat map, concat, merge, single or observable, everything. Relays. It's a common vocabulary defined in the Rx standard. And if you keep studying the standard, you're going to become better and better at using those operations in your application.
Thank you, guys. This is probably your longest mentoring session.
Don't worry about it.
I'm really grateful, and it's been really a pleasure talking to you guys. Yep. It was awesome. Thank you.
Thank you. Thank you very much.
Thanks for your time and for allowing us to share this with others as well.
Thank you. Thank you. Thank you so much, Andrew.
All right. Cool. Bye. Thanks.
Have a great night, guys.
Bye.